Can you see the screen now?
Yes.
Okay. Today class is music class. So you're going to learn UTM song. So you need to feel the DNA of UTM because you're going to be in UTM. Wait, I need to mute someone who's open the mic because it echo.
Okay, doctor, you can see me now, yeah?
Yeah, I can see you now. Okay, shall I start? Okay, I will start now. I want all of you to sing. Sapu mulut tak buka. Can you hear this one? Wait, can you hear? Hello. Can you hear the song?
Yes,
Doctor,
yes,
ada.
yes,
Doctor.
Shall I restart again? Nyanyi semangat sikit Did you hear the song for the first time? Is this your first time or you already hear it before?
It's first
Tak
time.
ada siapa tahu.
First time,
Because
first time.
you already second semester. Who else first time hear the UTM song? So I need to check back why you are still at UTM. Tiba-tiba tersesat pula dalam UTM but there is no DNA UTM. So first time, okay. Tadi siapa yang lambat? I don't want to be international because this is a Malaysian lyric. So I think Abdul Aziz, are you Malaysian? Where is Abdul Aziz? Abdul Aziz.
Yes, doctor. No, I'm not Malaysian.
You're not Malaysian. Who is the Who is the late person before Muhammad Abdul Aziz? I forget. Muiz. Muiz diam lepas tu dia tak buka webcam. Muiz, where's your face? You saya. Yelah you kan 2 megabyte tu kan. Tak apa. You buka mikrofon je. Kita tak tengok muka. So tak ada rasa malu lah sebab kita tak nampak muka. Okay Muiz, kita nak start nyanyi ni. Hello Muiz. Dia lari lah.
Ya saya.
Muiz, boleh nyanyi
Kalau nyanyi seorang-seorang tak sedap, dia kena dalam 5 orang macam tu.
5 orang.
Ha.
Lagu ni belum ada version duet lagi.
Dia kalau seorang dia tak sedap kan kalau
Version
nyanyi
solo
lagu.
je. Tak pun nanti you cipta lah yang version duet. Duet selalu pun 2 orang je. Mana ada 5 orang. Itu choir namanya.
Betul.
Apa? Okay, I give you chance to pick someone. Manalah tahu kawan baik you nak bantu kan. Want to help you to sing with you. Pick someone. I give you the guarantee to pick. Muiz? Gila.
Saya pick doktor.
Pilih je. Ada ramai ni Tak perempuan je.
Saya pilih Mayudin. Ahmad Mayudin.
Ahmad Mayudin. Laki betul dia ni. Okay, turn on your microphone.
Ya doktor. Yes
Okay,
doktor.
boleh So kita ada
Doktor, saya nak pilih lagi seorang boleh lah doktor.
orang
Tiga orang.
Itulah nama dia, orang kata bagi betis nak peha.
3 orang doktor. Limit.
3 orang boleh kat doktor, lagi sedap.
Okay, 3 orang je last tak boleh
okay.
tambah. Manusia ni tahu dia dah janji okay tambah lagi seorang nak tambah lagi. Last tau.
Okay doktor.
Siapa?
Muhammad Najib.
Najib, buka.
Mic problem doktor, saya tak boleh nyanyi
Mana pula? Tu ada dengar tu.
Saya sikit tegak ni.
Marilah kita nyanyi.
Tak ada rasa suara garau pun. Okay. So kita dah ada 3 orang. Kita tak nak lambat-lambat. Nanti kan kita start kelas lambat. So first kita akan dengar kita punya 3 singer. Selalunya UTM hasilkan student-student yang brilliant, but maybe somehow UTM can also produce new singer. So this is the opportunity. Maybe after this you can join mentor ke apa lagi? I tahu mentor je. AJL ke? AJL terus dah. Okay, are you ready? I share screen now. Jangan mute.
Ready.
Tapi
Ada doktor. Okay.
jangan mute. Wait, I share.
Muhyiddin tak boleh tunjuk muka.
So I need to mute my. If I mute, can you hear? I think I cannot share my screen because after that maybe ada distortion, right? So someone from one of you need to share your screen and play the UTM song at YouTube. Okay, seorang sebab dia kan, dia yang jadi pasalnya. Siapa ni? Muhammad Muiz. Awak yang drag kawan-kawan. So you need to play the music.
Saya takut saya share nanti lag doktor.
Pilihlah kawan-kawan you.
Maiden.
Sekejap.
Thank you Maiden.
Pasal betul lagu ni.
Lepas ni belanja KFC dia kata. Food Panda delivery.
Nanti claim idea kita.
Ni Irfan Mubin ni keluar masuk dari tadi.
Doktor, nak present entire screen ke tab?
It's okay as long as we hear the song. So kita nak tengok muka awak, bukan kita nak tengok screen tu. Tak payah share screen lah. Kita nak tengok muka. Kita nak tengok
Oh,
muka.
tak payah share screen.
Kita bukan nak tengok YouTube tu.
Dia nak
Okay, semangat semangat. So yang lain semua tepuk tangan.
Dengar doktor.
Dengar. Kita ada singer. Okay. Ingat lirik.
Wait.
Dengar doktor.
Nyanyi lah, dengar.
Okay, jap. Bersama kita menjulang unggulan terhilang kita usaha UTM puncak letaknya martabat keilmuan cendekiawan beriman
Cekal bersama
Takwa.
cita-cita
kandung UTM
Bunga
usaha
kami
Semangatlah
kamu
kau persada ilmu
keazaman perjuangan
perjuangan
takwa dan iman
ke arah
ras
kemenangan
kemenangan
jarak pendidikan
tulisan
Hussein
perkhidmatan kepada watan
di sini kami
Kami berdiri
Najib, you tak
setia
pada
pada
janji
bermaruah berbudi bahasa UTM sanjungan bangsa UTM sanjungan bangsa.
Okay, thank you. So today we have sajak version lagu UTM. So later on next class, so if someone coming late or maybe you did not turn on your webcam for Malaysian especially, but for international student, please also start to learn this UTM song because you are currently UTM student. You need to have the feeling of DNA UTM. Need to love UTM. That's why we learn UTM song today. Siapa type ni? That was very nice. You need to learn UTM song dia because you already second semester at UTM, right? So same goes to other international student. If you did not open your webcam next time, and maybe if you come late to my class in the middle of my teaching, so you need to sing the UTM song. Tiba-tiba sekali dah bosan dengan lagu UTM ni, I pick different song. So stand by. So now, I already share with all of you the video on our class. So I hope that you're going to watch it because now I'm going to continue. I'm not going to explain back because I'm trying to finish it all by this week, our module 1. If I cannot finish, I will just push up the video because mainly in this module 1, it's more into your understanding, your basic knowledge on computer. So it is more history and then more definitions, theory. I don't think that it's very hard. You can just also read it back and also hear my explanations. So in this class, I also record, so you can just playing it back later on in the YouTube video, isn't it? Okay. So I'm going to share the screen now. Okay, can you see? Okay. Yesterday we already looked into who's on the microphone. Can you mute first? Okay, thank you. Yesterday we already looked into an overview, and then last night I shared with all of you video almost 1 hour's duration, which is share on the components of computer and also computer structure and function. So in this class today, we're going to look into the computer evolution, and yeah, we see how much that we can finish it. So under historical development, so this will be very boring because this is history subject for me, but I do believe maybe some of you love history subject. You love to learn history story and so on, right? But for me, I think this is very boring. But what to do, you need to learn it. So the evolutions of computer can be divided into generations. So there is a few generations on computer also. Same goes to human. Now you are Gen Y or Z, I forgot. Something like that. So we have generation. Each generation being defined by the technology used to build the machine. So you can see there is a movement of technology on developments and computer evolution. So starting from 1642, berapa tahun ni? 200, 300 back. It's already starting, but it is not called as a computer, more to the mechanical calculating machines. Then after that, you have the vacuum tube computer and transistor computer, integrated circuit computer, very large scale integration VLSI. Now we have on top of VLSI, we have ULSI. So if let's say this slide or notes is not enough for you, maybe you want to learn more in the history of the evolutions computer, later on maybe I will share some video about the history of computer. So I'm going to continue. And if you check your slide also, you can see below here, they are the reference which is that we use for these notes. So you can refer back. Let's say over here in this slide, you can have the reference under William Stallings, the computer architecture, computer organization and architecture. So this is the book, and the pages also provided. So if you want to read in terms of the long sentences, who's coming late? So every time who interrupt me while we in the middle of our study, so this person will be singing at the end of the class. But okay, I think this one is international student, right? So I will teach slowly on UTM song. Don't worry. So you will be master, I think, throughout this COA class, and then after that you will master with UTM lyric and song. So I start again. Where is it? My slide. Okay, here, in the earliest electronic computing machines, programming was synchronous with connecting wires to plug. So you can see this is the old versions of the von Neum Neumann. So sorry, I cannot pronounce it well. So under this model, so you can check also what is this. There is a reference over here. And there is no layer architecture as this for this. So programming a computer was much of a feat of electrical engineering, as it was an exercise of algorithm design. So all stop program computer have come to known as von Neumann system using the von Neumann architecture model. So this is the all versions of computer. So we just learned on the history architecture of computer. So what is under this von Neumann model is used for designing and building the first generation. So this is the first generations of computer called as vacuum tube computer, because if you look into the architecture before this, the first thing is under more to calculating machines rather than computers. So the first one will be the vacuum tube computer. So that's why you use this von Neumann model to design and build our first vacuum tube computer. So if you want to see more what is basically the vacuum tube computer, how it's look like, you can search on Google also. Maybe I will also push, as I mentioned, I'm going to push and share with the video related to history of computer. So the basic models follow the three characteristics. So first characteristic is the computer consists of 4. So this one same also what happened with today, but I think over here there is no storage part, but it's okay. You can see this is the model basic 3 characteristic for the vacuum tube computer. It have memory, storage, okay, ALU, control unit, your processor, and input output. So basically this one is you can mesh it together. This is control unit and this is ALU. In the video I share you last night, you already know that it is arithmetic logic unit, so no need to keep repeating it. So program is stored in memory during execution. So this is the second characteristic of the basic model. And then on the third one is program instructions are executed sequentially. So over here, this is the structure of von Neumann machines. If you look, it's quite similar to our existing computer architecture and also structure. You can see that you have the main memory, which is we call as memory and also storage part. And then we have the CPU. That's why I mentioned to you that we can combine it together, because it's basically one part which is under CPU. And we have the input output function, not function, device, which is there is input and also output. Maybe sometimes also it can be a program, which is input program. So later on you will learn what is input output also. So is it okay for this? So this one is the volume bottle neat. So you can see over here. Single part is often referred as. So this is under structure of Neumann machines. Next, we're going to know that this is still under Vienna models. Conventional stop program computer have undergone many improvement over years. So this improvement include adding specialized buses, a floating point unit, caches memory, to name only a few. So departure from the classic von Neumann architecture, hence the non-Vienna model. So this one is you can read by yourself also just to understand the history and how the developments of computer from previous years. So this is the first generations of model. So you can see that it is adding processor and parallel processing are example of approach in non-von Neumann model. So adding processor can increase computation throughputs. So this one also same goes what happened today. If you want to add another processor, you can increase the performance of your computer. And then parallel computer, nowadays you are using the parallel computing. So for your third year, I think, or even for your fourth year, maybe you will meet me again because I teach also parallel computing subject. So please make sure you be careful yourself. Give me a good and beautiful comment only, okay? Because later on we will meet again. Next, you can see over here the modified von Neumann architecture. So when you adding a new system bus. So over here you have the CPU and then memory and input output. Over here you add another system which is called the system bus. Under system bus there are several, which is data bus, address bus and control bus. So this all is the system bus. So this is the versions modifications of von Neumann architecture. And this one is under processor. I think quite similar what we have learned yesterday about the computer, about the workstation, about the supercomputer and so on. So we look back, but this one is under processor. How it's developed. So since 1960, so we still not born yet, high performance computer system were equipped with dual processor. So 1960 ni dah ada dual processor. So if let's say you check your computer, they still using dual processor. So please check it. To increase computation throughput and throughout your COA also, COA subject also, later on you will learn how to calculate throughput. Now you don't have any idea apa lecturer ni cakap throughput. So later on you will learn what is throughput and how you going to calculate your system, your computer throughput. Then in 1917, supercomputer system were introduced with 32 processor. Siapa yang pakai 32? Now I think 64, right? So at this time we already come out with 32 processor. And then supercomputer with 1000 processor were built in 1980s. So 1980 series is already come out with the 1000 processor. 1999, I think at this time, after this you born, right? So in 1999, IBM announced it Blue Gene. So now we have the Blue Gene system containing over 1 million processor. So later on, if you still don't understand, you can also check over here below part. There is information for you where you can read the long versions of our compact slide over here. So under parallel processing, so this one I teach for parallel processing, HPD, high performance parallel processing and computing for year 3 and year 4 student. So parallel processing is currently most popular because we are currently using parallel processing in our computer architecture. And the only one method of providing increased computing power. So if you check what is parallel processing, what is parallel performance and so on, you will understand more. And you can also refer to this Linda Knowles and Julia Leber. So over here there is a publication under pages 30. So you can see also, because we pick from this reference, more radial systems have reinvented the fundamental concept of computations. These advanced systems include gen of your computer, quantum computer, and data flow system. At this point, it is unclear whether any of these systems will provide the basic for the next generation or not, or maybe you will come out with new processing system. Who knows, UTM can produce a student that can change this system. Currently we use a parallel processing. Maybe later on you will come up for our new generation of computer with different kind of processing style. So this one is our 4th generation of our microprocessor. So this is how it looks like. The chip is called as all CPU components on a single chip. So we have only one chip, so it's powerful, although it's small. It's only one, but everything was stored inside. The more elements were placed on each chip, so that fewer chips were needed to construct a single computer processor, because sometimes your computer having multi-core processor inside, right? So many processor you will need fewer chips. So you need to know what is your microprocessor, how it works, and so on. So this is the early evolutions in Intel processor from 1971 until 1974. You can see this is Intel, how it look like. This is the picture, and then after that it move. Makin kecil ke makin besar ke tak sure. You can see the exact size, but it's quite similar, right? Only different in their looks. But the pin you can see. So I guess in our digital logic class we already learned how to calculate the pin numbers, right? So you need to starting from here and so on. Same goes to here, pin 1 and pin 2 and 3 and 4 and so on. 1974, it's much bigger, I think so. Intel first general purpose microprocessor. So designed to be the CPU of general purpose microprocessor. So this is how it look like. So we can see used in the first personal computer called name as Altair. And the evolutions of Intel x86 architecture. So Intel has ranked as the #1 maker of microprocessor for non-embedded system for decades. So if you lucky person, let's come up with new processor. So maybe you can name it, so remove the Intel. So that's why you learn something. So you need to become someone that created something new, not just follow. Okay, after graduate, I will work under Intel. So you duduklah dekat bawah ni je. So please aim to be higher. Although I also not a higher person, but aim higher so that you can achieve higher benchmark for your achievement. So you can read by yourself about the evolvement of Intel x86, 8086, and then 80286, and then another one is the 32-bit design. This is the numbers of the processor, which is to support a multicast that run multi-program at the same time. So still this is the evolvement of the Intel's x86. Now you have the Pentium Pro. So it's look very different rather than if you compare to the previous Intel, which is Intel 4004. You can see it's totally different. It's look very smart over here, and then it's very nice to look like rather than you have this pin over here. So this is how it's moved. Maybe later on you will design different. Maybe you design it rectangle, or maybe this one is square, isn't it? Maybe you design it with a circle or maybe triangle. So who knows? Then you have the Pentium 1, Pentium 2, 3, 4, and then Ethenium, Cold War, 4th core. I think, is it 4th core? I think more than that also you have. So maybe you can check what is the highest highest processor available currently. So when you want to buy a new computer, new laptop, you will check on the processor. So this is how it's moved. So if you still using a Pentium processor, so it's quite slow rather than if you compare to dual core and quarter core and etc. Okay, next is processor and reason processor. So you can go through by yourself. It is same, but you need to know all and each just for your information and for your understanding to love your computer more. Because if you cannot know anything about your computer, how you going to love? And another one more things, when people ask you about computers, so you have the idea how you're going to explain what's about the core and so on, how is basically the processor are. Maybe you can explain also to the shop seller that sell the laptop and computer about the processor, what is basically inside, their virtual memory, their addressable memory, their clock speed and so on. Maybe they just know okay, you are using a dual core or maybe a Pentium 4, something like that, but they don't know basically what is inside. So if you have this knowledge, then you can be someone is in front and on top of others. So you can share your knowledge to others also. So last, another one, we still have plenty of time, so I just move. Is it okay? So under 1.5 computer level hierarchy. So over here we're going to look overview and also layer in virtual machine. So under computer, which is consists of many things beside chips. It's not only chip. You have many and a lot inside your computer, isn't it? So before a computer can do anything, it must also use a software. That's why normally you say, what software that we are using, what software that you are using. Writing a complex program require a divide and also conquer. So what is this approach? So each of program module solve a smaller problem. So basically one problem, you're going to have one program. So that's why sometimes you need long in programming just to solve one small problem for your computer. So complex. What happened to my hair? Complex computer system employ a similar technique through a series of virtual machine layer. So this is the layer. That's why you need to know also on the layer of your virtual machine. What is inside basically? From layer 0, layer 1, layer 2 until up to your level 6 under your user layer. So this is very important. This is not even history at all. So it also can be asked in your test and so on about the layer. How many layer? What is functions under layer 4? So you need to know, okay, layer 4 is assembly language. So the movement is from below, which is from your construct, your digital logic. That's why you need to learn digital logic first. Last semester, isn't it? So when you have digital logic, you combine all the circuit, all the gates. Then after that, you come out with the control level, which is microcode, hardwire. This I already share with all of you in our previous, in our video. And then you have machine, which is instruct set architecture. Then you have the system software. Assembly language, this is the one that you're going to learn also in your COA. And higher level language, C++, Java, and many others, C and so on, which is higher level language. And lastly, you're the one who whatever you are seeing over here, it is under level 6 user, which is executables program. You can execute any program that you want. So the machine at each level execute their own particular instruction, calling upon machine at lower level to perform tasks as required. So computer system ultimately carry out the work. Sorry, I want to check. Okay. So you can see and you can read one by one each level. So you have the level 6, your user, level 5 and so on. I already shared it the previous slide. You can read it, and if you have you want extra reference, which is where we drag this, we are picking up under this page number 26 in Linda Naus and Julia Lebres also reference. Level 3, level 1, and lastly level 2 and lastly the level 1. So you can see what is basically inside the common acceptable layer in our virtual machine. And a level 0, of course, the digital logic, which is the one that you already learned. So this is the combinations of all the gates. So we will move, I hope that because we have another 3 minutes, I will speed up because this one is an example system, so we can go through it. So you can see this section, we will introduce some vocabulary that is specific to computer. This jargon can be confused, impressive, and also, sorry, it's not impressive, imprecise and intimidating. For sake of decision, the next class has provided a facsimilized computer advertisement. So you can see over here, this is how your computer look like. This is the advertisement example. If you want to buy computer, of course, you're going to look into catalog and so on, right? So this is how the example, and it will share with all of you about the processor, what, how many storage and everything. So you can check it. So what does it all mean? So that's why you need to learn all. So now after COA subject, you will see that, okay, I can buy my own computer by myself because I clearly understand what was stated in all the advertisement and all the flyers that in the catalog of the computer or laptop that sells. So you can see over here what is L1, which is what PCI, what is megahertz, what MB, what USB, and so on. So without having a handles on just terminology, you will be hard pressed to know whether the state system is wide biased or even whether the system is able to serve your needs. So my kids already start screaming. So you can see over here, this is on a mathematical measurement. You can go through it because this is more mathematical. You already learned in secondary school, isn't it? About your thousand, million, billion, what is basically the numbering, what is the short form of that, the unit that you need to use, and so on.
It's 10 hours.
So whether a metric refers to the power of 10 or a power of 2 typically depend upon what it is a measure. So I think it's more on example. We already, now it's 10 a.m. So I will try to finish it and I will make another extra, only short video just to cover 1.6. As I mentioned, this module 1 is very and quite boring, especially for those who don't like history and also theory. So that's why please make sure that you go through all. Later on in module 2, we're going to play with numbering, so it's okay. You will not feel boring at all. So I guess we can finish our class by today. So any question? Is it I'm lagging?
No.
No, really.
No, that's fine. Thank you.
No. Okay. So whoever still did not scan your QR code, your attendance, please do so. And then for those still did not finish the video, please watch it because we're going to move to our module 2 for next week. Is it okay? So thank you for your participation, and don't forget also to learn the UTM song. Okay, thank you and bye-bye.
Thank you, Doctor.
Thank you, Doctor.
Okay.
Bye-bye.
Thank you, Doctor.